All right, morning guys. Oh, actually, I've lost the whiteboard. Yeah, if you could all comment your names just so I can do a quick register, that would be great. Cool. There we go. Cool. All right, nice. Cool. Let's just tick off some names then. Right. So Harry, Eliza, Finn, Oliver, Isla, Emily, Sally again. Yep. Cool. Anybody else? Yep. Still missing a few of yous. Cool. Rest of you just drop me a comment as the video goes. I'll make sure it gets filled in. Right. So yes, today I thought we'd look at kind of throwing together all of the hypothesis tests because we looked at three over the last few weeks, and whilst they all have similarities, you don't want to be able to, you don't want to get confused between the different tests. So I thought we'd start by mixing them all up, trying them, and then we're going to start working through a past paper, which will be the 2018 um, applied paper, and the next week we might start looking at pure again. Cool. And also make sure you're doing your assignments, guys. And if any of you do want your mechanics, want me to go over your mechanics test with you, drop me a message on Google, Microsoft Teams, and after college today, I'll do a quick one-to-one and just flick through pages, talk you through what you did wrong and any questions, and give you your overall grades. I will be emailing out the grades probably at the weekend, but if you want me to go over it in detail, please message me on Teams later. Cool. All right. So what I would like you guys to do first of all today is I've got three questions here. I'm just gonna try and fit this in better. Still a bit up. There we go. So three questions here. I'd like you guys to read through these and decide which one you think is which hypothesis test, just to start you off thinking. So which test is which, numbered 1, 2, and 3. So I'll give you guys 2 minutes just to have a quick think about that. If you could type your answers in the box, that'd be brilliant. Yeah, 2-minute timer. Can you tell me which of these questions is for which hypothesis test? Cool, Ollie, that looks good. You got another minute, so Ollie, if you could try and type what your reasoning was for each of those choices, that'd be great. Rest of you, see if you agree with what Oliver said. Okay, so the first one, as Ollie said, was binomial. The way you can tell it's binomial is it's talking about probability of success and a number of trials. So we've got a sample of 25 customers, that's the number of trials. And we've got a success is 1/5 of the time. So yeah, with those two together, and it's and to do with proportion. Those three things kind of make it very make it very clear that it's a binomial question. All right, question 2 then. How do you know it's normally distributed? How do you know it's a normal hypothesis test? Well, it mentions it in the first line there, normally distributed. We also know it's all to do with the mean. So if we read on, we've got sample mean. So again, that, and then we got the mean weight is different. So again, it's kind of clear that it's a normal distribution question. And the last one, we are testing the correlation. So it's clear that it's one of the correlation coefficient hypothesis test questions. Right, so we're going to try each one of these just so we got in your mind, nice and fresh, how to do each one of these hypothesis tests. So it's a bit of revision today. Could you guys try this one? So this is the one we said was a binomial hypothesis test. If you guys could try A, B, and C, and then we'll go through it in a second. So I'll give you 8 minutes to do this because it's worth 8 marks. And there you go. And then comment when you've got some answers. Yeah, Harry, so it's going to be a binomial question. Um, and you want to find the critical region. So we know the area. You want to try and find the value. So it should be inverse binomial. Cool. You go to, let's try and remember. You go to the distribution function on the calculator, which looks like a normal distribution graph. Then you're going to choose binomial and then inverse. Cool. All right, guys. Hopefully you remembered all that. Is tricky kind of flitting between all of these. So, restaurant owner notices, blah blah blah. So yeah, we got binomial. We'll start by stating the distribution, which is always pretty good way to start. So we've got x is binomial. Number of trials. If you read on, there's going to be 25 trials later. The probability of success is 1/5. We say where x is number of customers ordering lasagna. Okay, next we need to do our hypothesis as it says in part A. So H0 is going to be everything the same. So the probability is still 1/5. H1 is going to be the probability. So let's read through, and it says we'll change the proportion of customers. So H1P is not equal to 1/5. And we then say where P is the proportion, or the probability, it's up to you guys how you word it, the proportion of customers choosing lasagna. Cool. Okay, so we want to try and find this critical region. So that's the 5% level of significance to find the critical region. So if I do a quick sketch, just so you can see what we're doing. Obviously, the most popular, the most likely outcome is going to be a fifth times 25, which would be 5. So we're trying to find what the critical values are at either end of our distribution. So I'll just try and fit that in a bit better. There we go. So yeah, so we're trying to find these two critical values. And when we do that, we're looking at the 5% level. So each of our tails is going to be 2.5%. Or 0.025 for our probabilities. Okay, so the way we're going to do this is we're going to use the graphical calculator. You could do this on the ClassWiz as well, but bring up the calculator. We're going to go to statistics. On the ClassWiz, you'd go straight to distribution. So statistics, if I delete, this is all the data from yesterday. We're going to need all this table space. So if we delete all this. Cool. And we're going to type in our upper and lower values. Remember on the ClassWiz, you don't quite do this, but this one we need to. So we're going to go, I think we'll go from 5 down to 0. So 5, 4, 3, 2, 1, 0. And remember on the graphical, you need to put in the lower and the upper boundaries. So distribution, binomial distribution, BCD. Our lower value, we're looking at lists. We need to tell the calculator to use list mode. List 1, yeah, the lower values. List 2 is the upper values. Number of trials, well, there's going to be 25 trials. And probability of success is 1/5, which is 1.2. Right, so if we go to execute, it's going to give us all the values. So remember we did 0, 1, 2, 3, 4, 5. I think rather we did 5, 4, 3, 2, 1, 0. So we're looking, so let's just go back and check that table. Yeah, so we did 5, 4, 3, 2, 1, 0. Good. Okay, if I just go back and calculate that again. Cool. Right, so probability of being less than, we'll copy these down. You always want to copy down a few of these. So if I just get rid of the stuff we're not actually using right now. So we're looking for the first probability to dip below that 0.025 for our 2.5%. So we can write out the table, and this is what you do for the ClassWiz as well. Probability x is less than or equal to 5. 4, 3, 2, 1, 0. Bear with me while we copy this out. We just want it to be proper. And the values we get them was 0.6166, 0.4206, 0.2339, 0.0982, and 0.0273. So I do the last one? Yeah. And 0.0038. Okay, so looking at my values here, where does the 2.5% come in? So this one here is 2.7%. So this one here is going to be our first critical value. So we always put a line on here. This is the 2.5% level. These are the acceptance values, and this is the critical values. So critical value for this one, critical region, is going to be x equals 0 for part of our critical region. Yeah. Now we're going to do the same thing again, but with greater thans. So we want to try and look at the other end of the distribution. So I'm just going to try and make a bit of space. Not much space anyway. Yeah, so let's just write it in. So we're going to try and do, we'll go x is greater than or equal to 7, 8, 9, and 10. Now on the graphical, we can just type these in. On the class Wiz, remember, the class Wiz is only do less than or equal to. So you'd need to do the whole greater than 7 is 1 minus the probability less than or equal to 6. Okay, I'm not going to do that now because I don't have the class Wiz. But that's how you do less than for a binomial cumulative distribution. Right, so we're going to need to change our upper and lowers. These are now going to be the lower values. The upper values are now going to be 25. So if we go back to the calculator, back to the list, we're going to have 7, 8, 9, and 10. Get rid of the rest. And all my upper values are going to now be 25 because that's the total number of trials. I've left out 9. Good, good, good. Do that again. 9, 10, 25, 25. Be careful when you're typing stuff in. Okay, so same thing again, distribution, binomial, BCD. Lower is still list 1, upper is still list 2. We don't need to tell it anything different. And execute. So we'll drop down these probabilities and then we'll have a quick talk about what's going on. So 0.22, 0.10, 0.10491, 0.0467, and 0.0173. Cool, there we go. So again, we're looking for that 2.5% level. So the 2.5% level, this one's 4.6. This is now 1.75%. It's going to be in between those two. So again, the top ones are all the acceptance region. And then down here, we've got our critical. So I make our critical regions to be equal 0 or x is greater than or equal to 10. for our critical region. So if we found either 0 customers ate lasagna or 10 or more customers ate lasagna, we would then reject H0 and accept H1. Okay, what's the probability of incorrectly rejecting H0? Well, that's the actual significance level in our test. And find that we're going to add together our two percentages from this one. So if you add those, you get 0.211, 0.0211. So 2.11% overall that we've somehow done it wrong. Cool. Anyone got any questions on that? I'll just pause it here for a sec because that's it for binomial hypothesis testing. Okay. Anybody else here for attendance? Because Tom, I saw that you've arrived, so I'll tick you off. Still missing Lucas, Ruben, and Ben. If you guys are around. Okay. So next question is going to be the normal distribution one. So we've got weights of cats in a town are normally distributed. Have a read through. It's worth quite a lot of marks. This one 12-mark question. I will give you guys 12 minutes to do it. So see how you get on. Does anybody need any help? Please comment if you do, guys. And when you start to get answers, do just type them into the comments. Is the right sensitive difference you want the class with? How do you mean for this one for normal distribution? Well, the defining Z. How do you mean the right side of the table? So the class viz only does less than or equal to probabilities. So if you need to look at, if you mean the right side of the distribution, maybe, yeah, you need to use the probability, the whole less than probability every time. Sigma, yeah, is 0.4 good. Yep, minus 4.2, well done. Right, how did you guys find that? So the 0.801. Yes, I agree. Do you guys want a little bit more time, or do you want me to go through it? Give me a comment to decide. But basically, to give you an overview, then the first one was a using Z to find mu and sigma, and then using that mu and sigma to do a cumulative normal question to find the probability between two values. So there's quite a lot in that. That's why it's worth 6 marks. Part 2 was a binomial distribution question, pretty standard. And then part 4 was a normal hypothesis test for the sample means. Do you want 2 more minutes? I feel like no one's answered it yet. I know all these done part B. Yeah, I reckon I'll give you guys 2 more minutes to see if you can finish off. So 2 minutes on the clock. See if you can do a hypothesis test. Cool. 2 minutes starting from now. Sorry, guys. Yeah, so I've put in our bits they've told us. So we told 2.5% of cats weigh less than 3.416, and 5% of cats weigh greater than 4.858. So I've drawn all that in our picture there. So we can use the calculator with those values to try and find the z values that correspond to those x values. And then we're going to use the coding to try and find mu and sigma. So if I bring back the calculator, so we'll do the lower tail first. So distribution, normal, inverse normal, tail to the left. We're not going to do list, we're going to do variable for this. Area there, 0.025, 0.025. Sigma, well, we're doing a standardized distribution, so sigma is going to be 1 and mu is going to be 0. And if we execute that, we get our z value, so that's 1 minus 1.96. So I've added that to my sketch for that z value there. Okay, we're going to do the same thing for the upper one. On the graphical, we can just change the tail to right. Obviously, on the class Wiz, you're going to have to do 1 minus the area. It's not much harder. So we're going to use 0.05 on the class Wiz. You'll be doing tail to the left and 1 minus 0.05. Same thing again, though. And this time we get Z is 1.645. All right, so there's our values. We're going to use the equation Z equals X minus mu over sigma. And we're going to solve those simultaneously. So we're going to put the Z value in. Minus 1.96 is the X value, 3.416 minus mu over sigma, and 1.645 equals 4.858 minus mu over sigma. So we're going to solve those two equations simultaneously. And when you do that, we will get sigma is 0.4, mu is 4.2 at the top there. Cool. Right, once we've done that, we still haven't solved the question, but we've got everything we need now. The rest should be pretty straightforward. So what it's actually asking us to do is find the proportion of cats that are of standard weight, and standard weight is between 3.5 and 4.6. So 3.5, 4.6. We want to try and find this area. We now know our mean and our sigma, so we could say the weight of cats for weight is normally distributed with a mean of 4.2, a standard deviation of sigma squared there. And we're going to find the probability that x is or w is between 3.5 and 4.6. So this is another job for the calculator. So if we go back there, we're now looking at a cumulative distribution. Lower 3.5, upper 4.2. Sigma is 0.4 and mu is 4.2. Cool. May as well draw it. It's always fun when you get the chance. So there's our graph. That doesn't feel right to me. It's not. The upper should be 4.6. There we go. Let's draw that again. See, if I hadn't drawn it, I wouldn't have spotted that. That looks more like my sketch. Good. Yes, we get 0.8013. Cool. Good job, anybody that got that. Okay, now we're on to our binomial part. So let's get rid of this. So 15 cats are chosen at random. So already we've got a sample size starting to feel like a binomial question. Find the probability at least 10. So we've got x is a binomial with a sample size of 15. And the probability of success we just worked out 0.8013. And and we're going to find the probability at least 10 cats, so greater than or equal to 10. So back to the calculator, looking at a binomial distribution this time. BCD, our lower is going to be 10. Upper, well, 15 trials, so the upper is going to be 15. Number of trials, 15 trials. And probability of success, 0.8013. Execute, and then we go 0.9406. So that's the probability at least 10 of the cats are of standard weight. Cool. All right. All right. Let's write that down then. So 0.9406. So yeah, Ollie, good job so far. Last bit then is our normal hypothesis test for the sample means. So we now have a mean distribution instead of our one from earlier. So our sample means, we'll use weight of cats with a line on it so we can see its mean. It is normally distributed. And we're testing whether the mean is different from 4.5. So that's going to be our mean. Remember, our sigma squared is going to be the standard deviation 0.51. Remember, it needs to be squared because this is the variance, and then we're dividing it by the sample size, 12. So that's my distribution. And what are we trying to do? Yeah, so we're trying to do a test. So we need to state our hypothesis. So our null hypothesis is that the mean is 4.5. And our alternate hypothesis, if we read through, I can't remember what it is. Yeah, we're testing whether it's different. So different means it's a two-tailed test. We're testing whether mu is not equal to 4.5. So we're going to test at 10% level. So we need to do a lower and an upper tail, 5% each. And we're trying to find what these critical values are. So 0.05, 0.05. So it's going to be inverse normal, find those two values, and then we can actually do the hypothesis test. So distribution, normal, inverse normal. Again, we'll start with tails to the left because that's what the class Wiz calculators can do. And type in 0.05, which is already there. Sigma this time is going to be 0.51 divided by the square root of 12. It's a bit more confusing than that one. Mu 4.5, as they told us in the question, and that should do it. So our lower value there is going to be 4. Have I done that right? Let me just double check this. That has come out different than what I did earlier. Area 0.05, yes. Sigma 0.51 over root 12. And mu 4.5. Yeah, cool. Okay, so yeah, we do get 4.2 there, so let's write that in. 4.258, let's say. And our upper value, we do the same thing, but with greater than. So area, tail to the right. If you're on the class Wiz, again, you have to do 1 minus your area, but nothing else changes. Calculate. We get 4.72. 742 even. Okay, so those are our critical values. So now we actually need to do the test. So we've got our critical values. Their sample mean is 4.73. So 4.73 is not going to be critical. So 4.73 there, we somewhere in here. So we can say 4.73 less than 4.742, therefore not critical. Therefore, there is no evidence to suggest the mean weight of all the cats in the town. Don't want to leave that out. Of all the cats in the town, all cats in town, sounds like a band, is different. 4.5. I've run out of space there. You guys probably can't see the writing. Yeah, so no evidence to suggest the mean weight of all cats in town is different to 4.5. Cool. Has anyone got any questions about that one? So this is what we were doing before the Easter holidays. Okay, last hypothesis test I want you guys to do is a test on the sample means like we learned about yesterday. I'd like you guys to try and get this one done on your own, but we'll see how that goes down. Yeah, see how you get on. So, relatively straightforward question. 4 marker. So I'm gonna give you guys 5 minutes because it is the newest topic in hypothesis testing. Give it a go. You need to type stuff into the calculator, but it should be okay. So, a few minutes to get this one done. Yeah, you might find that useful. Give me a sec, I'll just find the copy of it. How many do you need? 6, 7. Cool. There you go. Cool. Right, let's give this one a go. So 2.5% is going to be our test level. So let's look for 2.5%, which is here in the middle. We've got 1, 2, 3, 4, 5, 6, 7 values. So we're on the 7% sample size. So yeah, the correlation we're looking for, we're trying to find if there's negative correlation. So right, let's do some hypotheses. So H0, row is 0. H1, row is less than 0. And our critical value 0.7545, or technically minus 0.7545. So for there to be negative correlation, the value we get as our correlation coefficient should be less than that. So let's have a look on the calculator. And we need to type in some data. So I'm going to get out the way. Cool. So what we got? 17.5. Okay, we need to work out which is x. Normally x is on top, but let's double check. Yeah, I think temperature will affect pressure. 17.5, 18.5, 18, 24.6, 22.2, 23.1, and 27.3. Cool. Is that right? Yeah, 7, kids. And now we're going to type in the other values. So 10, 10, 10, 11, 10, 997, 109, 998, and 102. Just going to check those through because it's really easy to type in stuff that's rubbish on the. Yeah, good. Okay, so we're going to go to what are we doing for these? We're trying to work out the regression of it. So we're going to go calc, setup just to check. Yeah, list 1 and list 2 are there correctly. Good. We're going to do regression, X, and we want to find the PMCC, the R value. So we get R is minus 0.792. Run out of space there. Cool. All right, so here's my value. That is less than that. So that is a critical value. So we say, if I get rid of this graph for now, no, it's huge. There you go. Oh my god. Cool. All right, so we're going to say minus 0.792 is less than minus 0.7545. Therefore critical. Therefore accept H1 evidence to suggest negative correlation between temperature and pressure. So as temperature goes up, the pressure goes down. Cool. Right, anyone got any questions about that? So that's what we were doing yesterday. All right, so what I wanted to do for the rest of today and for Friday's lecture as well is to start working through a statistics mechanics paper. So I've got the 2009 paper here. And I think the best way to do it is to give you guys the number of marks, amount of time to try, like we were just doing, to be honest. But now we're looking at actual past paper questions. So if you guys could try this one to start with, can you all see that? Is that big enough on screen? I'm gonna go with yes, just so we got a bit of space to write in. But maybe I'll make it bigger on the zoom in version. So if you guys, this one is 2, 3, 4, 5 marks. If I give you 5 minutes to do it, yeah, see how you go on. But we're doing this past paper. Ask Harvey if you need it, because some of these are things you won't have done since last year. So please ask for hints if you feel like you need it. keep forgetting to turn the mic on. Damn. Okay, so I made a probability distribution, which is basically just a table showing the outcomes, the x values here, and the probabilities. The x values, so the sky is measured in eighths. We call them octaves. So there's the possibility you can have a full sky, sevenths, sixths, fifths, all the way down to 0, the sky is completely non-cloudy. The other key bit here is the normal distribution. Normal distribution means, a uniform distribution means that the probabilities of each of these outcomes has got to be the same. So there are 9 outcomes in total, therefore each of the probabilities should be 1/9. So we're asked to find the probability the cloud cover is less than 50% of the sky. So 50% of the sky would be 4/8 of the sky. So we want less than this, so it's going to be 1, 2, 3, 4/9 in total. Okay, next bit is comment on the reliability of the model. Well, the model says that the probability should be 0.44. The actual probability is 0.315, which is quite a bit less. So we could say model unreliable. Value is less, so his value is too far off. Too far off. Okay. Last bit, how could we improve this model? Well, the cloud cover isn't uniform. The probability of it being completely sunny or completely cloudy isn't the same on any given day. So using a uniform distribution is probably not a good idea. So one good refinement would be don't use a uniform distribution. So a binomial distribution could be better. A non-uniform distribution could be better. A continuous model would be better. Yeah, the other thing you could say is using data from more locations to create your model. But the main one is don't use a uniform distribution where the probabilities are the same for every outcome. All right, on to question 2. So question 2, when it loads, this one's a little bit smaller, I'll make it a bit bigger. So we've got a product moment correlation coefficient question, which then turns into a linear regression model and basically interpreting the linear regression. So this is all stuff we've been doing this week. 7 marks, how long we got left? We got 13 minutes. Cool. All right, we'll do this one and then we'll probably end on this one for today. So give you guys 7 minutes to give this question a go. How's everyone getting on? Anyone need any help? Yeah, I suppose you guys do need the table again. Sorry, I keep forgetting about that. This one. Cool. Okay. So we'll go through this one and then we'll do the rest of this hopefully on Friday. So Tesla owns a small shop, records the weekly sales figures and the weekly temperature. So we're looking at the correlation between sales figures and temperature for 8 weeks in the summer. So key bit there is we're looking at 8 weeks. And they found the PMCC is minus 0.915. So we need to do a hypothesis test. So state them clearly. H0, row is 0. h1. So we're trying to look if it's negative again. So we're going to do row is less than 0. All right, so we're going to look through the table to find our test statistic. So we've got 8 weeks. So that's the 8th column. And we're looking at the 5% level of significance. So we're looking at 0.6 or minus 0.6215. Now our value is less than that. Our value is more extreme than that. So therefore we have except H1 critical evidence suggests a negative correlation between temperature and weekly sales figures. Okay, suggest a possible reason. So it's a seaside town. Where's everyone going to be when it's hot? Probably at the beach. So we can say seaside town when hot, people at beach / not shopping. Okay, so she suggests a linear regression model could be used for this data. Do you think that's wise? So she got minus 0.915, so that's very strong negative correlation. Therefore, linear model would be good. So well done, Oliver, with your answer for that one. So yes, strong correlation. Therefore, regression, linear regression is suitable. Cool. Okay, state which variable will be the explanatory variable. Okay, so which is causing the other thing? So I think temperature is causing the sales to change. So explanatory variable is going to be our weekly temperature. Average weekly temp. And last bit, give an interpretation of the gradient that she's calculated. So I need to make some space there. So the gradient is 171. So the interpretation would be, or minus 171, for every increase, so for every 1 degree C increase in weekly temperature, average temp, weekly sales decrease by £171. That's pretty extreme, isn't it? So every degree in temperature rise leads to a drop in earnings of £171. Cool. So pretty easy question, but you have to understand what you're really talking about with these ones. Okay, cool. If no one's got any questions, then that will be it for today. So Friday, we're going to keep going with this paper. And however far we get on Friday, I'll probably stop and set it for homework after that. If any of you guys, my face is going a bit green screen there. If any of you guys want me to go through the mechanics test, drop me a message on the Microsoft chat at 4:15, and we can go over that. If you need any help with workshop stuff, I can be available at 1:10 as workshops were before. Just send me a Teams chat message and I'll have a bit of time to go over any questions that you might have. And make sure you're doing the assignments and the skills checks and uploading those onto Moodle as I said already. Cool. Right, cheers guys. I will speak to you all on Friday. Cheers. Thank you. Bye.